Hi, hello 3E. This recording is for continuing the lesson on work energy power for today, Thursday. Sorry that I can't be physically with you. Nevertheless, I would not want to waste the time missing the lesson, so I would like to continue with you on uh, this lesson. We are coming to the last part on power. I hope to complete it with you so that we have time to catch up on the revision starting next week so that you are better prepared for your WA2 that's around the corner. Okay, so can you please turn to page 8? All right, page 8 of your notes. Page 8 of your notes where you see this page on power. Okay, get ready because I'm going to go through the PowerPoint slides just like you would see in the classroom, except now you are opening it up, this pre-recorded slide from Google Classroom so that you can watch it on your own. Please use a headphone or please use a headphone so that you won't disturb your friend beside you. All right. So here I am showing you the slide now. Okay, so on page 8, we are coming to the last part called the power. Okay, previously you have learned work done, kinetic energy, potential energy. All these are measured. All these three that you have learned in the past are measured in joules. So they are all energy. Okay, work done, kinetic, potential, energy. They are all energy. They are all measured in joules. This is the only one in this chapter that is different from the rest. It is not energy, but it is very closely related. So how do we first define power? Okay, um, power is defined as the rate of work done. Whenever we say rate of work done, the word rate, the rate of work done always refer to 1 over T. It involves uh, the time, the time needed, or the work amount of work that's done within a given time. Okay, that's why now it is work or rate of work done. Of is times work done is times work. That's why the formula is power equal work done over time. However, many a times it is remember work is also energy, so the formula is also energy over time. So you can write this beside W over T, beside the work done over time, it is also uh, E over T. So P is, and many a times I also write in multiplication form, just to know that when E is related to P, yeah, when you want to write the relationship between E, energy, and power, it can be written this way, lah. Okay, E equal power times time. That this is another way of showing the formula. E equal power times time. So there are three ways to show the formula for power, depending on what the problems would like you to solve. If work done is given, then you write W over T. If this kinetic energy, potential energy given in the question and there's time given, then you write energy over time. Okay? So this one is a multiplication format is an alternative. Sometimes you just want to find E with a given power and a given time. You can very quickly write in multiplication format. So uh, you take your time to write this down now. This formula actually only one. There's only one formula, just that it can appear in these three different form. Okay, there are no. It is not three different formula. They are all one single formula. Energy over time. All right. So what? How do we measure power? All right. How do we measure power? So uh, if you want to write in this triangle format, power will be energy over time, right? So if you want to measure energy, you cover energy, it will be power times time. If you want to calculate time, you cover time, it will be energy over power. All right. I think you know this triangle uh, to help you in remembering the formula before. So I leave this to you. You want to write this in this triangle or not, I leave it to you. Okay. Now, power, P is measured in, oh, sorry, P is measured in watt. P is measured in watt. Let me delete them one by one. P is power and is measured in watt. Okay. You can see it measured in watt. So it is not like energy. Energy is measured in joules, but power is measured in watt, W-A-T-T. In short, it's also W. So if you try to memorize what is W, it can be quite confusing in physics sometimes because W represent weight, right? W also represent work done, and W now also represent watt in unit. All right. So not to worry lah. Later when you see more formulas, more example coming up, you will know what to write for power. Now work done, W again is in joules, or it can be energy. It can be uh or the denominator part. Remember this E part. Uh, this E part can be in uh, energy in joules. And when I say energy, it can be any kind of energy. It can be kinetic energy, it can be potential energy. Okay, so long anything that's measured in joules, when you divide by time in second. Okay, in second. Let's look at this. Okay, time taken in second, it will give you power in watt. When you take energy in joules, divide by time in second, it give you power in watt. All right. Uh, so point 28, SI unit. SI unit for watt is W. Since the formula is energy over time, so one watt can also be 1 joule over 1 second. So watt can actually be written as the unit. Unit for watt can also be written as joule second to the power of minus 1. Just to let you know, sometimes you see joule per second, it also means watt. Okay, take some time to digest that because we are going to look at the formula, how to apply this formula in some simple question now. This is the last part, it's not difficult. Okay, uh, just know that this formula is used most often in your O level, so you can mark 2 star. It is used most often in your O level. However, sometimes this formula, which is rarely used, also appear. This formula rarely used, but it can also appear sometime in very rare question. So let's see how we come to F times V for velocity. Okay, from work done can also be force times distance, right? All of us know force times distance. Okay. However, uh, However, distance over time is also speed, right? Speed equals to distance over time, right? Which means now the formula can become force times speed, which means the formula can be written as force times speed. Uh, Good to know this, but rarely used. Okay, this formula rarely comes about. Of course, the V is the velocity and it must be measured in meter per second, SI unit. Okay, so just take note that this formula is rarely needed. However, in order to show its application, later the last question in your notes, we will take a look at how this formula is applied. All right. Okay, now let's go on to the next slide now. Next slide. Okay. Example 13, point number 30. Okay, so let's look at one example of how electric motor, this formula power equal energy over time can be used in the simplest way in this very easy question. Okay, so an electric motor uses 600 joule. I don't know what energy is this, but down here the question say it is an electrical energy. So it's neither kinetic work done or potential energy. But now I see an electrical energy and it is measured in joule. So this one tells me it is an energy. Okay. And it is used for 30 seconds. It is used in 30 seconds, which means this one is my time. So what is the power? What is the power? The P equals to what? Okay. What is the power of the motor? So now you can look at the formula P equal energy over time. So this example I work with you first. Okay. And uh you should see that it is 600 over 30 seconds. 600 joules over 30 seconds. Right? Okay. And with this, cancel off the zero, you will get the answer 20. But remember, you are measuring power, therefore your answer should be in watt. You are measuring power. You're calculating power, your answer should be in watt. Easy, right? Okay. So power is basically using any energy over any time, which must be in second. Now, next one, just to stress the importance of the time in second, let's take a look at a slightly complicated question right now for the next one. Next one, okay? Now, allow me to show this in presentation mode, yeah? Okay? So, you can see that I marked 2 star for this because I see this question in O-level 10-year series very often. It's about a man running up a flight of stairs. So here I have a man, okay, running up a stairs. All right, running up a stairs. And what else did he say? He ran up the stairs in this flight of stairs in 3 seconds. So I know the T is 3 seconds. All right. But if the man weighs 600 Newton, wow, that's important, right? 600 Newton. That means I must draw a vertical arrow downward to show that the weight is 600 Newton. Okay. Now, to carry himself vertically up each time he run up the stairs, he must go one step up vertically, carrying his own weight of 600 Newton. Now, if I were to ask you calculate the work done, what is the work done by the man? All this has a purpose. Part A, you calculate the work done. Later on, part B is for you to calculate the power, which you need to use the work done later on. Okay, so work done first. Work done equal force times distance. So what other force can you see in this question? Only the 600 Newton, right? 600 Newton. So work done equal force times distance. It will be 600 Newton multiplied by which distance? Is it the 5 meter, 4 meter, or the 3 meter? What do you think? Which one should it be? Can you think for a few seconds? 5 seconds. Remember, force times distance, it must be parallel. These two quantity must be parallel. So since your weight act vertically down, the parallel distance is the vertical 3 meter. All right. So you should take this 600 Newton times 3 meter. You should get 1,800 joules. Now the part A, you have calculated the work done. Second part will sometimes ask you for what is the rate of work done or what is the power. Power is the rate of work done. Okay. So you have work done over time. Can you do this yourself now? You are given the timing 3 seconds. Okay, 3 seconds, and your work done you have calculated in part A. So quickly try this yourself in 10 seconds. Press your calculator and let's see the answer now. Okay. So 7, 6, 5, 4, 3, 2, 1. Okay. Let's look at the answer. Okay, 600 watt. Okay, 600 watt. Simple, right? It's easy, right? It's all related. Part A asks for work done, part B asks for power. And there's a reason why part A asks you calculate work done so that it can be used in part B. All right? Okay, now let's look at the next example. Do you notice I highlight something important? The light bulb has a power of 100 watt. So this is my power, this time is given. How much electrical energy? This time energy is what? Does the bulb use in 5 minutes? 5 minutes. Well, this is my T. And 5 minutes, you must be very sensitive to this. 5 minutes doesn't look like the correct unit. You have to change it to second. So you have to ask yourself how to do this question now. Okay? See, notice the question asked for energy. So knowing the formula energy and power, how they are related, also important is you can quickly relate to it. So come, let's look at the formula. E equal PT. All right. Now, what is the next part you have to fill in? Power is 100 watt, right? But what about the time? Can I just write 5 minutes only? No, right? So it will be, to change it to second, it will be 5 times 60. All right. So the time now is converted to second, in second. Okay, times 60. So this is very important because especially O level like to play with units in the problem sum. They like to give you units that are not standard SI unit so that you remember. They hope to test you out and see whether you remember to go and try to change it. Yeah. Okay. So you would get 30,000 joules if you see that coming. All right. We are near the end. Okay. Example 16. Example 16. That's point 33. An engine delivers a power of 500 watt to the speedboat. It moves at a constant speed, but this constant speed of 10 meter per second, 10 meter per second. Yeah, important, huh? So I have the speed equals to 10 meter per second. Just take note of that. What is the force? Suddenly ask about the force. This is not asking about resultant force. No, it's not asking about resultant. If it's resultant force, the question will ask, what is the resultant force? Then you all would know the answer straight away. Object moving at constant speed. Newton's first law. Moving at constant speed, resultant force must be zero. But this question is not asking about resultant force. It is asking for what is the force the engine delivers to the boat. It is the forward pushing force for the boat, not resultant force. Yeah. Okay. So see, they give you power not for nothing, right? Power is given. Speed is given. Then suddenly ask you for what is the force. Can you quickly think of the formula that we have previously talked about that is rarely used? Rarely used. Okay, so I can see P, I can see V, and I can see F involved here. So the formula that comes, which I think is good to know, good to know. But I must stress that this kind of question rarely happen in O level, but good to know. Okay, good to know. So power can be equals to force times speed. Okay, all right. So to find your force, it can be force equal to power over speed. The rest is history already. The rest you can, I give you quickly within 30 seconds to do now. 30 seconds. Please do it now on your own. 30 seconds. So it will be power over speed. Power over speed. Okay, so what answer do you get? Let's check. 30 seconds. Almost up now. Okay. 29, 30 seconds. Okay, 30 seconds up. So what is your answer? Did you get 50 Newton? Okay, so power over speed. This is this is the kind of problem where knowing this formula will help a bit lah. Okay, it will help a bit. If you ask me, if I don't know this formula, then how? If I don't know this formula, is there a way to solve it? There is also another way, but I think we don't want to stress on that here because this kind of question rarely happen. Okay, all right. So with that, we have actually come to the end of the chapter. All right, that's the end of the chapter. The last part, power. It's all about taking energy divided by time. All right. So then when I see you next week, if I can come back, all right. When I see you next week, I would like to start the revision with you on next year. I mean what you learned last year, pressure as well as mass, weight, and density. All right. So uh, hope we have not wasted the time because I'm absent. Okay, today. All right. So take this with you. That's the end of the chapter. Um, Also, on the piece of worksheet on law of conservation of energy, I understand that we only try the very first question. The next two questions, you can do it as a homework. In fact, right now, if we have ended and you have extra time left, please take a look at question two and question three in that piece, one piece worksheet. Let me come out of this. Okay. That one piece worksheet, if you remember, okay. Sorry. Yeah, not to forget this worksheet. Yeah. Okay, this worksheet, right? We have done this question. If you have time now, you can proceed on to try question two. Okay, question two. This will be a very good try. Try in pencil so that if anything wrong, I can come back and confirm with you. I mean, I can come back and double check with you. All right. And also try question three if you are fast enough. They are not difficult. If you think a bit, you can get it one. All right. So I'm going to leave this session with you. The rest of the time, please, yeah, try your best. Okay. That's all. Thank you.